Hello everyone, welcome back to your Anemone course. Today's second part we will start looping and geometry using object-oriented programming. It's a paradigm in scripting and programming that talks about creating templates or classes of functionality. For example, we can talk about the class of a car. A car is an object with four wheels that moves along a direction. We can talk about different properties of different cars, which we can call then objects. We can talk about the color of the car, the number of doors, the type of engine, or whatever we want. We can use classes to replicate this template in order to create as many objects as we want with different properties. So let's get started with this in a very abstract way in Grasshopper. What we want to do is we'll create a polygon . Two polygons actually. I want to create lofts. I want to do this in a more controlled manner in Grasshopper, so let's get started. First off, I need my start polygon, my end polygon, my start target plane, my end target plane. Please copy and paste this and connect like that. So what I need to do is to reorient each polygon to the target planes. So I will orient the first polygon based on its origin. The target will be the start plane. I will repeat this for the end polygon. End polygon, end polygon, and target plane. After that, I need to wave between these two. Make sure these inputs are grafted. Loft. And connect up your rep component. Like that. There we go. This is a template of functionality. We can actually test it. But before that, just copy everything, paste it, and select all these from the inputs of curve and planes through loft, right click, cluster. There we go. We can call this a class in a very abstract way. This is the start polygon. This is the end polygon. Target start, target end. There we go. We can just delete this. We can test our class creating polygons, different segments, say 5 and 3, different sizes as well. There we go, we got 2 different polygons, and we need 2 target planes which we can generate from a line. For example, we'll go to Rhino, draw a line, curve, reassign, Grasshopper, we'll hide this, we reparameterize the curve, we create pair frames, the beginning and end at parameter 0, and parameter 1. Okay, so now we can actually test. There we go. We're actually making it work properly. This is what we wanted. We are reorienting a polygon, a set of polygons to a set of target planes, and we create a loft. What if we want to do the same thing? I will preview off this. What if I want to do the same thing using a polyline? Let's just try it. Polyline. Points on. We'll move the points on the Z direction to make it more visible. Okay, so I got my curve. So one curve. Okay, I exploded the curve. Now I need to create my set of polygons. I will copy and paste these ones. Got the start and end polygons, my curve, and I need to explode polyline since my script works with lines. I need to calculate first of the twin curves between the first and last polygon. So in order to do so, I need to calculate the number of vertices. Here we go. Create a range. Remember, doing this -1. I'm going to twin curves from polygon start to polygon end. The parameters will be these ones. There we go. We got all the transitions between the polygons. And I also need to create the start and end planes for each segment. Start and end planes for each segment. So we'll just get the segment reparameterized per frame. Fetch at 0. Fetch at 1. I got 8 start, 8 end, but I got 9 transitions. This is, we need to graft this list. Okay, I need to shift the list of the twin curves in order to get 8 start polygons and 8 end polygons. So just go to shift list. This to make it grab shift by 1, which is by default, and shift by -1. There we go. So this is the start polygons, which are 8. I will graft, and end polygons, which are 8. And I will test my class, which I will copy and paste. Start polygon, end polygon, start target plane, and target plane. And there we go. It's actually working, but we have issues here. We'll have smooth transitions between each line. This is because we need to calculate average planes, which are actually congruent with each other based on the x and y coordinates, and that's how we will start using loops in order to create it. So first off, we need to start over, copy the curves and the polygons. We'll turn off everything else. Okay, so let's calculate average planes first. We need to explode the polyline. And we need to calculate average plane, for example, between these two transitions. Everywhere we have a transition. We don't have transitions at the start and end segments of the polyline, so we need to get these ones first. This is the start and this is the end one. At the start we need a perp frame at 0, and at the end we need a perp frame at 1. Remember to reparameterize the segments. There we go. After that, we need to calculate the average transitions between, when we have two segments. So let's shift our list of segments. Remember to ungrab the list. shift by 1 and shift by -1. After that, we need to deconstruct the vectors of h. We need to add the x component with the x component, y with y, and z with z, and calculate average divided by 2. X, y, and z. After that, we rebuild a vector. X, y, and z. Using this information, we can actually rebuild the tangent planes at each vertex. We need to graph this output of vector, and we need to remove the first and last vertices as well. So just go to co-index vertices. We need to remove the 0 and -1. We graph the list. We create plane normals. This is the origins, this is the z-axis, and there we go. We got average planes. We only need to flatten and to insert the very first and last planes. So I go to insert items. This is the list. This is the first plane at index 0. And then we need to insert the last one. This is the list. This is the last plane, and index go to -1. There we go. We'll turn everything else off. And this is my whole list of planes. After that, well, let's recalculate the twin curves. We can actually just copy and paste what we actually did for chase all this block and replace connections. Curve A, curve B, list length is the vertices. There we go. So I got 9 planes, I got 8. These 9 planes I have to reassign. Actually, remember, we need to shift list in order to create the start and plane and end planes. So shift list by 1, don't grab, and by -1. There we go. We got the start and end planes, but at the moment we don't need to make this calculation actually. Because what we need to do is we need to rebuild all the planes based on the very first one. So the x and y coordinates, they are all congruent. You can tell these x and y coordinates are not the same ones as this plane and the next and the next. So we need to rebuild all these planes. So we'll just get rid of this, and we will start a loop using this loop start, loop end, and we need additional input. And right click, record data, make this connection always. We'll just leave this like that. First off, we need to get the x and y points of the very first planes here. Let's calculate them. First item, the very first plane. Deconstruct plane. We will move the origin by the x vector. We will move the origin by the y vector. We will merge this list. And there we go. After that, we need to introduce the data, which is this one. X and y start points. X and y coordinates of the plane. After that, we need to retrieve several data based on the counter. So let's get to list item. First off, we will get from all the planes the ones who are actually calculating the iteration that corresponds So we'll connect the counter to index and list to all the planes, which is this output. Okay, so I need the first and the second plane. I also need to get the very first polyline, or the current polyline. I will use the counter as well. Counter. Now we'll get the current segment of the polyline. Very good. I also need to get the vertices using counter as well. I will go to vertices. Now I need the first and the next one, so I can recalculate planes. And I need the corresponding twin curves as well. So just connect another one to twin curves, which is this one. I'll get rid of this shift list thing. Okay, after that, what I need to do is to rebuild the planes based on the x and y coordinates of the very first plane. So let's get started. What do we need to project? We need to project these points, which are the x and y points. Towards which plane we want to project? We want to project the first and second planes. So just this, copy and paste. This, which is the projection direction, will be the polyline segment, the current polyline segment. There we go. We got the x and y planes. Next, we need to create lines from first point to its corresponding x and y coordinates, and from the second point corresponding x and y coordinates. To that, let's get list item x, which is index 0, and y. Do the same process around here in constructed plane. The origin will be the first point. This is x and this is y. There we go, and we have to repeat x, y, and the origin, replace it by the second point. These planes are now congruent with each other. We'll turn off the rest. You can tell the x and y coordinates are the same ones for this plane. After that, we can actually start creating our geometries using our class. So we got the start polygon. Our start polygon will be the first polygon, first twin curve. Then polygon will be the second one. Target plane. The start is this one, then this is the end. We'll turn this on. You can tell it's actually working. Now you can bring this into a recursive process just by adding this into my loop, and using data I will use the projection points. We'll use the projection points of the second iteration of the second plane. Sorry, we have constant and record to that. Let's set up the number of iterations. The number of iterations should be the same amount of segments minus 1. So let's calculate list length. Polyline segments. Here you go. Minus 1. This is the number of iterations. And there we go. Actually, we got it working pretty well. I can actually change the values of the segments. I forgot to use a button. We can restart loop. There we go. It works pretty well. So this is a very effective way of organizing planes using loops and making them work properly. using classes, of course, which is this block. You can start clustering blocks of functionality in order to make our life easier. Okay, so that's it for this tutorial. Thank you all and see you in the next tutorial. Goodbye.